Welcome to Full Stack Live, my live coding channel, and welcome to my Linux shell workshop, where we continue where I left off last Friday. This is the second part of my Linux shell workshop. We started Friday last week, and the recording is on YouTube. So let's see. This is my slide deck, and let's simply go ahead. We talked about what a shell is and talked through a few basic shell commands. And we arrived at the file system. As I already mentioned last week, file system in Linux is hierarchical and consists of a single tree. Other than, for example, in Windows, where you have a tree for each device with the drive letter at the top, we have a single slash at the top, and everything else that's available in terms of storage and even additional information that is not really storage is available below this single file system tree root. Hey Yoingster, hey, welcome. Welcome to Full Stack Live. I appreciate you dropping by. You are new to scripting with Bash. Well, I hope this live stream is going to change that. I'm not sure if we get to actual scripting today, but it's in the cards, definitely. So, this file system tree, and if you wonder why it's called a tree, you probably need to rotate it and put it on its head, and then you can see that the slash is the root below and branches, and the file system branches up from there. So it's an upside down tree. Thing is, even if you have additional storage media, like for example a external SSD drive or USB stick or something like that, there will only be one file system tree ever, because everything is a file, and even the root directory of a separate storage device is a file in our singular file system tree. And that might look like this, for example. So here we have a USB stick called USB32 and a network storage called NAS, and they are both located below the media directory here, and which is directly under the root of the file system. So the nodes in black here are on the so-called root file system, which is there when your system boots, and shortly after, or when you plug in a USB stick, the other media might appear in this file system tree under media. It'll always depend on how you configure things, of course. This is just an example. Right, last week's one was useful. Looking to be a pro like you. Thank you very much. I'll happily take this compliment. I hope this part will be as useful as last week's was. Maybe even more. We'll see. Okay, so we'll get to the intricacies of the file system later. First, I just wanted to make it clear that there is only a single file system tree, and we started to work with Linux shell commands that work with the file system. That's the pwd command that tells you where in the file system tree you are at the moment. As you can see, I'm pretty much down the tree here. Under my root, file system root, there is the MNT directory, where the Windows subsystem for Linux mounts all drives. And then we have our drives under MNT. I'm not sure if I have additional drives already existing under MNT. Yes, I do. There is an E drive, and then there's the WSL and WSLG directories. Not sure what these are. They surely only appear when you are in the Windows subsystem for Linux. And as you saw, I already used another file system command, the ls command, that lists files in a specific directory. In this case, I gave it the directory in question as an argument. If I simply do ls without an argument, I get the contents of my current working directory, which is mnt/c/users/gbis/dropbox/documents/writing/optative course Linux Shell Workshops, Linux Shell Workshop examples. Okay, what's next? We have cd, with which we can change the working directory. So if you want to change what pwd displays, we need to use the cd command. And there is a specialty, which I can show you after getting into the details of ls, which is that you can use either absolute directory paths, as I did before, where I said, okay, show me the contents of the directory slash, meaning start from the root of my file system, mnt. So show me the top level directory mnt, and ls did that. There's also a way to work relatively, because there are two special directories in every directory on our file system. Linux adds them automatically. They are kind of virtual directories because they are placeholders for other directories, and it'll get clear what I mean in a second. Because if you use the ls-a option, you'll also get hidden files. And in the Linux file system, all files that start with a dot or even consist only of dots are considered hidden files and by default not displayed by commands like ls. And even graphical file managers and things like that might not show them by default. So as you can see, besides my regular files example.txt and workshop.txt, there are two additional file system entries, which are called dot and double dot. The dot directory exists in every directory, even the root directory, because it simply stands for this current directory. So ls without an argument is in effect the same as if I give ls the dot as an argument, show me the contents of my current directory. Why is this important? Why do we need to have an explicit directory where the current working directory is meant implicitly even already all the time? Well, for example, if you want to execute a command, Linux might not by itself find your command even if it's in the current directory, because Linux will only search for commands in specific places, mostly in the directories that get maintained by the operating system itself. So if you install new packages that come with commands, they get installed in specific places, and Linux will look in these places. If I had a command in my working directory here in examples, Linux would not by default find it. But here I can get explicit and tell Linux, I have a command, please find it here in my current directory. And if, say, example.txt was a command, I could explicitly execute it by saying, in this current directory, look for example.txt. This will work if this was a command, and I would simply say example.txt. This would not work, even though it's sitting right there. Now, I can't and will not execute example.txt, so it doesn't make much sense if I press enter now. And so here's a tip on the side. If you want to basically abort what you've typed in and get a new shell prompt without executing what you've typed in, simply press Ctrl+C and you get a new shell prompt without Linux trying to do something with the command example.txt. So that is another way to navigate directories. If you use cd to go through your file system, if I want to go into my home directory, which is mount c users GWIS, it makes sense to say cd mount, oops, still need to get used to keyboard, mount c users GWIS. No, it's not. So here it makes sense to use the absolute path, but if I want to just change back into the parent directory, for example, the Linux Shell Workshop directory, then I can use the second virtual directory that is available in all directories but the root directory, because the double dot directory stands for the parent directory. So in order to simply go one level up in my directory tree, I can simply say cd ... instead of cd/mount c users GWIS Dropbox documents writing operative course Linux Shell Workshop, which is a little bit faster. So from here, you can see there are two subdirectories. They are colored in purple, examples and slides, and then there's a file called preparation.md. I remember also showing you another option for ls, which is ls-l, which is the long form where you can actually see the size, for example, of files. This file has 58 bytes. As you can see, directories also have a size, but that's not actual disk space. The size of directories is measured differently, and I'm not going to go into the details now because it's not that important. But if you like, you can, for example, send me a question over on the Opsitive DevOps community. You can join for free, and if you're really interested in details, say, of file system structures and things like that, pop into the Linux topic and I'll answer your questions there. Okay, let me think if there is anything else that I'd like to show you in these very basic commands, which with which everyone will be familiar who's been on the Linux shell for at least a little while. So I'm not going to waste much time here. Let me see. What's next? Well, yeah, okay. So now we need a few commands that help us build and manage our directory tree. And mkdir is the first command that we'll see here. It's pretty straightforward. It does what the name insinuates, which is make a directory. For example, I can make a directory test. And now I have another directory called test. I can also make subdirectories. So I could make a directory test/subtest. However, in this form, this requires the leading directories here to exist already. So test needs to exist. If test wouldn't exist, then I'll get an error. We can provoke that. Let's do a mkdir test, test2 slash subtest2. Oh crap. Okay. This demonstration failed. Let's see if test2 actually contains a subdirectory. Yes, it does. And the reason is that I've reconfigured my own shell to use an option by default without me typing it in explicitly. And that option is the -p option that allows you to create a whole directory path. So even though the mkdir command should have failed, I'll demonstrate it to you how it would have worked properly. What happened behind the scenes is that it executed the command mkdir -p test. Let's make another one. So test3 slash subtest3. That's what happens if you demonstrate stuff in a shell that is already highly customized. At least I managed to delete my shell history before starting the stream, so I'm not going to be worried as I was last time to reveal something personal. Well, okay. Let's show another option, which is called -R. And this option, it goes recursively through all subdirectories and lists their contents as well. So if I execute ls-r dot here, I'll see everything that is in my current working directory and in all directories below that. As you can see, I get the directory itself, and then it's here, and then it lists the examples directory, it lists the slides directory, and my test2, and test3 directories with their subdirectories. Execute.io, welcome, happy Friday to you. I hope you're doing well. Happy to have you here. And thanks for redeeming the posture check. Let's sit upright for a bit. Actually not sure if I need a new chair, because sitting like this feels actually more healthy than what my chair allows me to do in its most upright position, which isn't actually upright, I think. It's a used Aeron chair I bought more than 10 years ago, and I'm pretty happy with it, but I'm not sure if I should get a new one that allows me to sit actually really perpendicular to the floor. I'm fine, even though my voice is still cracking after talking for a while. It's nothing serious. It's, I think it's to do with my asthma, from which I'm suffering a bit lately. But I had a doctor's appointment yesterday, and I got a new medication that might help. Luxon28, hello! Welcome. Happy to have you here again. I hope you're doing well. Welcome to part 2 of our Linux Shell workshop. I'm still recapping and completing things a little bit, so let's go ahead and jump to the touch command. So mkdir allows me to create directories, but what about files? Of course, I can use specific applications to create files. I could use a graphics program to create an image file. I could use an editor to create a text file. But if I simply want to create a file for creation's sake, I can use the touch command. I can use, for example, let's go down into my examples directory, actually. So, or maybe even go down in one of the test directories. That way I can remove stuff easily later. So if I show the contents of this directory. There's only the subtest directory that I created earlier, but by executing touch test.txt. By the way, there's another thing that might not be obvious if you're new to Linux. I entered touch.txt, touch test.txt, and press enter, and I got a new prompt. Nothing happened. There wasn't any output, there wasn't any file name displayed, and anything. And that's actually a good thing, because in Linux, getting no output back, especially getting no error message back, means everything is fine. As long as you get no output, you're fine. If you're getting output, it might be the output you expect. For example, if I enter ls, I definitely do expect some output. But with commands that don't have to visually display stuff, like the mkdir command or the touch command here, they won't do any output. And that's why many of these commands actually have a specific option to make them a little bit more talkative. It's most of the time, say in 90 to 95% of the cases, it's the -v option, and V stands for verbose. So I'm actually not sure if touch has a verbose option. There's not much use to it, I guess. But if there is no output and you don't expect any output, the command was successful. I'm not sure if execute.io is throwing me bones in the chat, or if it's a genuine question. How can I tell if the command succeeded regardless of output? There is a way, but we'll talk about that once we get deeper into shell specialties like variables and stuff like that. For the time being, no output where no output was expected is good. So let's see if it was actually successful. Yes, there is a file, and let's find out how big this file is. It's actually empty. Test.txt has exactly 0 bytes, so it's a lifeless shell of a file. Okay, yeah, I can see there are bones coming from that corner of the room. That's all I can expect touch to do, even though I said test.txt, which insinuates that it's going to be a text file. At the moment, I still don't have the tools to create a text file with actual content, but that's not what we're talking about at the moment anyway. I mean, I could always open this file in a text editor, be it a graphical one or a terminal-based one, and enter my text. And there will be additional ways to get text or content into files as well. That's going to be covered when we talk about input-output redirection. By the way, if you have any questions like execute.io and Luxan28 already did, please pop into chat and ask. Don't think that this is a lecture that you must not interrupt. This is an interactive thing here, and I'm more than happy to answer any questions that might be there. I might postpone my answer to a later stage in the workshop, but I'll do my best to eventually answer your question to the best of my knowledge. Okay, so that's touch. Touch definitely helps if you simply want to create a file because for some reason you need to be a file and you need there to be a file. It's a great little tool. Why is it called touch? Its original purpose is to update the last modified time stamp of the file. without actually modifying the content of the file. For some use cases, we need to be able to update the last modification date of a file without making changes to it. And Touch does exactly that. It marks a file as touched in terms of last modified timestamp without actually touching the content of the file. So as you can see, I've been talking for a while, and test.txt had a modified file of 1631. Let's make sure that's still the case. Doesn't update by itself. No, it does not. But if I repeat my command here, touch test.txt, you can see the last modified timestamp was updated to 1636 current time, but the file still has 0 bytes of content. Alrighty, let me get a sip. Now, rmdir remove directory does exactly the opposite of what mkdir does. There's not much that I'm going to talk about here. I'll simply demonstrate it to you. And rmdir, just like mkdir without any options, has its limitations. So if I change directories into, say, let's go to the parent directory. So if I want to remove my test2 and test3 directories here because they are not needed anymore, I could use rmdir to get rid of them. However, this command will fail because the directory test2 is not empty, and as you might recall, test2 contains the subtest2 directory. So we can't rmdir test2 quite yet, but we can first rmdir test2/subtest2, because this directory doesn't contain any more directories or any files. We can remove it. Now test2 still does exist, but it's empty. Now we can also remove the test2 directory itself. Is there a way to remove a whole directory branch? Let's take a look at the man page of rmdir. There is actually an option that I can use to get rid of my test3 directory by using the -p option, or the long form option --parents. I can remove a subdirectory with all the parent directories I've named. So rmdir -p-abc is similar to rmdir abc, which will remove the C subdirectory, then ab, which will remove the B subdirectory, and then A, which will remove the A directory as well. And as you can see, this would have been an intermediary step where you can give rmdir multiple arguments. So instead of doing rmdir subdirectory by subdirectory and working my way up, I could have also said rmdir test2/subtest2 and then test2 as the second argument, and both the subdirectory and then its parent directory would have been gone. But let's give this a try. So exactly like -p allowed mkdir to create a whole branch of directories, we can use rmdir -p to remove test3, subtest3, and then immediately the test3 directory as well. Now, what's going to happen if I also remove test here? Let's say rmdir test subtest. I get an error, failed to remove directory test, permission denied. Now, why did I get permission denied? The reason is, if I take a look, test still does exist, yeah? There is still a file inside of test. And rmdir is not allowed to remove directories that are not empty. I'm not sure why the error message is permission denied, though. That seems like a very misleading error message, actually, because it's not that I don't have permission to remove test. I created it myself, so I am well out to also remove it again. But let's see. We need to remove the test.txt file first, and there is, of course, a command that is able to remove not only directories but also normal files, and it's the rm command without the dir suffix. Rm stands for remove, and it can remove any kinds of files. So we should be able to say remove test/test.txt. Now the test directory is empty, and I should be able to remove the test directory. See, no permissions issues at all. It's just that before test wasn't empty. Guess someone was lazy with writing error messages and said, well, if rmdir-p fails, it's probably because of permission issues, so we'll simply output permission denied. But yeah, it doesn't really tell you the whole story. That's a really great tip that Execute.io wrote in chat. If you continue to get that error on an empty folder, make sure to check for hidden files, files that start with a dot. Sometimes you're not completely in it, or might have a little bit of a headache like I do, and you keep trying to remove a directory and always get these strange errors. And that might be because you didn't think of hidden files. Well, let's stay with the rm command for another second or two. There are two statements that I've made during this Linux shell workshop that we can now combine. Just recently I said rm can remove any kind of file. And last Friday I said, and I even have a slide about that, everything in Linux is a file. And that goes specifically for directories. Directories are also files in a technical sense. So if rm can remove any file, can rm also remove directories? Yes, it can. Let me recreate the situation we had before. So I'll do a, sorry about that, recreate test with subtest as a subdirectory. And we'll create a file. test/test.txt. If I want to remove test and everything that is in there, which will also include hidden files, I can simply say rm test. Or can I? Cannot remove test is a directory. So was it all a lie? RM can't even remove directories? Do I need to hand in my Linux Geek card? No, I don't. I just need to use a different option here. I need to tell RM that I want to remove a directory with all its contents, which means I want RM to go down recursively into the subdirectories and their subdirectories and their subdirectories until there isn't anything anymore. And that's the -r option. In this case, it's a lowercase r, and by saying rm-r test, I don't get any error message back, and no error means success. So the test directory with everything that was in there is gone. Do you need to be really, really careful with using this -r option? Well, you answer that question. Let me take a look if there is anything else that's important here in terms of options. Here we have the -r option. Actually, okay, I didn't know that. There is a -r with a capital R as well, so we can use both options here. -d will remove empty directories, so rm-d is pretty much what rmdir does, I'd say. The rm command definitely has a -v option that makes it more verbose. In this case, rm will list all the files it removes, so we can see what's actually happening. Execute.io asks the absolutely innocent question, is there a way to be careful when doing rm-r? Maybe something that lets me confirm? Well, yes, there is. As you can see, there's the -i option, where it actually asks me if I actually want to remove stuff. And so -i is a nice companion to -r, because I quickly see if rm goes astray, I'd say. Let's give this a try. What happens if I have my old hierarchy, make dir test and test subtest, and we'll also create a file in test. And now I can use -r combined with -i, and again we can make this a little bit more compact by writing them right after another. rm-ri test. And now it actually prompts me, do you really want to descend into test and start removing stuff there? Yes, please. Do you really want to remove the subtest directory? Yes, please. The regular empty file, test.txt. Well, since it even tells me that it's an empty file, I will probably say, yeah, get rid of that as well. But there might be a scenario where I say, oh, I thought these directories were empty and I just wanted to clean up. There's actually another file. And then you can actually say, no, don't delete that. I need to copy it elsewhere or do something like that with it. And now it asks me to remove the directory test. If I now say yes, I'd expect it to fail because thanks to the fact that I didn't approve the deletion of test.txt, it can't delete the parent directory either. Good. And thanks for the question, Exegeteo. A command that I can't actually demonstrate to you because it's only available on macOS is the open command, but I'd like to mention it because it's actually quite useful. With open, you can basically simulate a double click on the specific file that you give as an argument, which means if I say open picture.jpg, it'll open the image file in the default application, which will probably be Photos or Affinity Photo or something like that, or Pixelmator. If I say open index.html, if I have a HTML file, it'll open it in my default browser and things like that. And there are quite a few occasions where I'm missing the open command from macOS. And with the -A option of open, you can even start an application itself right from the command line. A graphical application, I mean. So you could simply say open -A photos and it will launch your photo library. But as I said, I can't demonstrate that anyway, so let's leave it like this. Now, just a minute before, I said I might even have to move a file out before I delete the directory hierarchy that I wanted to clean up, not knowing that there was a file left. So the mv command is there to move files in the file system. So if I do touch test.txt, not realizing that I'm not in my test directory, instead I created it on the same level as the test directory, I can say move test.txt into test. And just to make it clear that test is a directory, I'm adding the slash, but it's not necessary. Linux itself is smart enough to actually know, yeah, that's the test directory. So now the test.txt file is gone because I've moved it into the test subdirectory. What I can do as well is rename files, and that's where move mv as a command is named slightly weird, because from my experience, I'd say at least 50% or even more usages of mv are for renaming files instead of moving them around the file system. So if I want to rename my test directory, I could say move test experiment, and in this case it renamed test into experiment, and inside experiment there's still the test.txt file. Sometimes you need to be careful because this command here, mv test experiment and mv test.txt test without the slash, look exactly identical. But up here I moved a file inside an existing directory, and here I renamed an existing directory to a new name. If by accident the experiment directory had already existed, move would have actually moved the test directory into experiment and made it a subdirectory of experiment. So be careful and rather take a look at the contents of your directory first, so you don't run into strange effects. Let me just demonstrate that for you. Sorry, my nose is itching. So I'll revert what I did before. I'll rename experiment back to test. But this time, I create a directory called experiment. So if I use the same command as before, which I can do simply using my cursor keys, by the way, as I demonstrated last time, you can get commands back. So if I do another move test to experiment, expecting it to be renamed, because I didn't notice that experiment actually already does exist, it'll also be successful. But this time, I'm not going to find the test.txt file in my experiment directory, but the test directory. And if I no, let's take this differently. If I simply do a recursive listing of my experiment directory, then you'll see instead of renaming test into experiment with test.txt being direct below it, I actually moved test into experiment, and test still contains the test.txt file. So that's at least something that happens to me from time to time, that I do a move with the goal of renaming something, but instead I'll end up moving it somewhere where I didn't intend it to move. So that's that. And as you can see from the man page for MV, there's also a -i option that makes things interactive, so you get prompted before it overwrites files. The -n option does something similar, so it does not overwrite existing files. -f does the opposite. When you're really sure that you know what you're doing, you can use -f and not get a prompt even before overwriting files. So if you have something that you are okay with losing, you can use -f. And there should also be a -v option that makes the command verbose, so you can see on the screen what's happening. Well, and then there's the cp command, another dual letter command, which most of the time means that it was one of the early commands that were available with early Unix versions back in the 70s. The cp command copies files, so it does actually create duplicates. Let me see. So now we have our experiment subdirectory. Let's say I'll create another test directory, and I want it to contain a copy of my test.txt file. Then I can do that using cp experiment test.txt, and copy that into the newly created test directory on this level. I should probably vary my directory names to not make things too confusing. And now let's do another recursive display of both the experiment and test directories. Now you can see experiment still contains the old test directory with its test.txt, and the new test directory contains a test.txt as well. And of course I can also make duplicates with different names, simply by using not a target directory as the second argument, but a new file name. So here we have a test.txt file, and I can actually copy that into an experiment.txt file. There are two files, and had test.txt had content in the first place, experiment would now have the same content. So this way, they're of course still both 0 bytes. Now you can see that they might be identical in terms of content. That's why you do copy, but they are not identical in terms of metadata. As you can see, test.txt was created 1701 and experiment.txt was created a minute later. Most of the time that doesn't matter, but if you are using CP for, say, backup purposes, it might matter, because you don't want to have all your backup files on, say, a different storage system get the current timestamp because they were created at the time of backup. And once you lose your original files, you can still recover because you can copy over your backup files, but they'll have a timestamp from the date of your backup and not their original timestamps, and that might make things complicated. It's definitely not a one-to-one backup. And that's why CP also has additional options that even apply the copying to the metadata. So, sorry. You have to tell it work in archive mode. So I'll say -A. And this time I'll also use the I option, which again makes it interactive and prompts me before I overwrite files that I might not want to overwrite. And I say, make an archive copy of text.txt into experiment.txt. Now, experiment.txt already exists, so it will ask me interactively, do you really want to overwrite this? And yes, I want to. And if I do another ls-l, you can see they have the same timestamp. Even though it's now 1704, experiment.txt got the same timestamp that the original file test.txt had. Exaget.io asks in chat, were all the early commands two-letter because it was easier to type on punch cards? Yes. In the early days, you had machines like this one that didn't have a monitor, that didn't have a keyboard, that were actually fed with paper tape. I don't think the digital PDP-11 had a punch card reader. There might have been one, but all the demonstrations of the old machines I saw were with paper tape. So a long tape with holes in it, and having commands that only had two letters definitely made things easier. And even one generation of human interface devices later, you had a teletype as a terminal, where you could actually type stuff on a keyboard and get your output not on a screen but on paper. Even then, having only to type 2 letters must have made things much easier. And CP is only 50% of, say, copy, or MV is 50% of the word move. And even you Germans out there, would you rather type MV or verschieben? Okay. So, yes, CP is definitely worth looking up in its man page, because there are a lot of options, like the -A option. There is also the backup option that, instead of overwriting files, will make backups of the destination files that already existed. So there's even a way to copy stuff over an existing set of files without having to fear that some of them might get overwritten. And of course, there's also, in the end, the -V option that again will list what CP is actually doing. By the way, I've never demonstrated that, so let's give it a try. If I do... let's go back. One level here, and let's do another copy here. Wait, let me just orient myself. How does my tree look like from here? Test has experiment and test, and experiment itself has the test directory, which only has the test.txt file. Experiment got created later. So if I copy the test directory where I'm at again into experiment, we should get some overwritten files. Let me see, what was the actual option? --backup. Or simply -B, where I don't have an argument. I guess the argument here allows me to, gives me finer control over how these backups are made. So let's simply use -B here. So CP -A for archive copies, B and I'm intentionally missing one option. So copy test into experiment. Oh, it did work. Yes, -A actually implies what I thought I was missing, which is recursively going down a directory tree. There's the -R option that makes copy work recursively, which means go down and down and down and down.
It's a Unix system. I know this.
Welcome, I am Kaiser Wilhelm. How you doing? Welcome to Full Stack Live, Your Highness. Yeah, so I expected -R to be necessary here, but it's not required because A already implies recursive mode. So let's take another look into experiment now. Let's see both the long form information and recursive for experiment. So we have the test subdirectory, yes. We now have a copy of experiment.txt, which still retained its timestamp of 1701, because that was from the original test.txt. And there is an older test.txt tilde. That is the backup copy of test.txt that already existed in experiment before I ran my most recent copy command here. So I did not overwrite the original test.txt file here. Instead, it was renamed to a backup name here and then replaced by the newer test.txt file. So if you only have a few files that you'd like to back up, cp-a probably combined. No, I wouldn't combine it with b per se, because you don't want backups of your backups of your backups, but the cp-a command is quite useful. Okay, so what's next? ln. Okay, that will require a little bit of explanation, but since I've already been talking for over an hour, let me take a short break and then we'll get to links and what is behind them. See you in a minute. Are you okay with the music? I know it's really soothing and might actually put someone to sleep, but so far I've been enjoying it. ln. Okay, how do I explain ln? It creates file system links. Well, yeah, okay. And so df shows you... No, I'm just kidding. How do I get back? What are file system links? Now, I guess that requires an illustration that I might have... that I should have prepared already, but thankfully we can do that also spontaneously. So, how does a file system work? Well, you have your file system tree with a slash, and then you might have your home directory. And below that, we'll have my username. Let's also paint some nice arrows here. And there might be other users' directories as well. So Alice might have her own home directory here. And then I have my files, huh? So let's maybe change color to symbolize files. Let's make them blue. So I have, say, I might have a welcome.txt in my home directory. Now, what is a file, technically? A file consists of two kinds of information. There is, of course, the actual content of the file. And that's part of the file that actually takes up significant disk space. But then there's also meta information about the file, for example, its name, and there's also other information like who created it, and as I demonstrated before, you can also see when it was last changed. And this information is stored in kind of a table. But to keep things simple, I'll simply use a red arrow to symbolize that there is a file name entry under this directory, but the disk space the file content occupies might be somewhere and will be somewhere completely different on my disk. So I have this name and maybe a little bit more information about the file. So let me actually say, okay, this file belongs to GWiz and it was created today. That's the file system metadata, and that then points to a place or even multiple places on the disk where the actual content of the file is stored. And that red arrow here basically is what in Linux is considered a link. The meta information is connected to the actual file content by a link. And the ln command allows me to create additional links. So if I go back to my shell and we go into test, I can actually use ln like the copy command and say test.txt to test2.txt. Okay, now I get actual output even though the command was successful, so that's a bit of an exception to the rule. So if you take a look, there is now another file, test2.txt. And if I take another look, closer one, I'll also see that test.txt and test2.txt are completely identical in terms of my metadata. Even though test.txt was created 20 minutes ago, test2.txt has the same metadata, and I didn't even use any additional options like -a that I had to use with the copy command. And that's because ln isn't the copy command. What ln did here, let's clear this up. So I had a test.txt. What ln did was create a duplicate of my entry for test.txt named test2.txt. Inside this directory, but this file entry points to the same content. So that's the main difference between ln and cp. cp would have also copied the file content. So I would have used up twice the disk space then. In this case, I don't. In this case, I have two file system entries that point to the same file, to the same content. And the funny thing is, now I can't even distinguish which one was the original and which one was the link that I created later, because they are completely identical twins. They are not even twins, they are two identities of the same disk content. The same disk content now exists as two different names. I should have named this file born.txt, because that would have driven the point home, I guess. So, what happens if I delete one of these? Before, when there only was the tests.txt, and I would have said rm test.txt, not only the directory entry with the name and stuff, but also the actual disk content would have been deleted or at least freed up for reuse. Now, that would be catastrophic, because if I remove test.txt as a directory entry, and it then removes the actual file contents, then I would have an orphan entry test2.txt that has lost its actual own content. And that's why Linux keeps a record of how many entries are pointing to the same storage. So if I now remove, I can't demonstrate that without having actual content in the file, and that's actually something that I can nicely demonstrate. Let's use my text editor and change the content of test.txt. So we have, this is test, meaning this is the test.txt file. Well, let's make this explicit. So if I use cat, which we've discussed before, on test.txt, it'll say this is test.txt. Now, what happens if I do cat test2.txt, which before had 0 bytes? It's not too much of a surprise, I think, since both file entries pointed to the same file contents. By modifying the contents of test.txt, I, of course, modified the contents of test2.txt, because they're not only identical, they're actually the same. And in terms of removing files, or let's first take a look at the file sizes. Now they are both 18 bytes, and they will always be identical. And the modification date, it will, well, that might be a coincidence. It's now 1727. Let's see if I can touch one of these files, meaning I can update their file date without affecting the other. Nope, I can't. By updating one, I'm updating the other as well. So my diagram here isn't 100% accurate. It's actually only the file name that's managed separately. All the metadata is actually in the file contents as well. it's connected to the file content. So by modifying the metadata of the file, it'll always show with both links here. And finally, removing one link shouldn't actually catastrophically pull the rug from under the other one. And I can demonstrate that by removing test.txt, which was our original, which we remember Linux doesn't really. For Linux, these two files are mirror images of each other. Except that if I delete one, the other still keeps existing and keeps its content. As you can see, it still has 18 bytes. Let's make sure the content is actually identical. Yes, it is. So as long as there is one directory entry, one file name that points to the actual file, the file contents will be preserved. Once I, of course, remove the last instance, it'll be gone, and my disk space is now freed up. Okay, this was the most complex command that we've covered so far. Do you have any questions? Is there anything that I should explain again? Would you like me to make another demonstration or something like that? Because I know sometimes when things suddenly get more complex, it might be hard to follow. Maybe you also had one of these, oh, so that's how it works moments. And I'm happy if you share them too. Let's let my voice catch a break a little bit. Okay, let's take another step into the details of LN. These links are called hard links because they are reflected directly in the file system. And even though I had both of my links in the same directory, that's not required. So I still have my experiment.txt file. I can actually go into the experiment directory and create a link to test experiment.txt here under the same name. So I'm using the dot virtual directory to say create a link right here. And now I have an experiment.txt file. The original was empty, so this one is empty as well. And as you can see, this hard link has also the old modification time of the original experiment.txt over in test. It didn't create its own metadata. And if I change this file, I will automatically change the other one as well. Let me demonstrate that quickly. Let's edit this. This is experiment.txt. So our newly created experiment.txt has this content. And if I go back into my test directory. There's still my experiment.txt, but suddenly it has 24 bytes of content and a new modification date, or time at least. And as if by magic, it now has the same content. Now there's one downside to these magical links, and that is that it's absolutely not obvious which file entry is a link and which is not. Let me return in 4 weeks and take a look at these directories. I'll never realize that these two files called experiment.txt, located in different directories, are actually the one and the same file. Hello, user 129835. Welcome to Full Stack Live. Happy to have you here. We're talking about file links in the Linux file system. Yeah, hard links, as they're called, are not really obvious. And sometimes you want to see that there isn't a directory entry that is only a placeholder for a different file. And there's a solution for that. It's called symbolic links. A symbolic link let me create one for you. Maybe go back to blue. Did we have? I think we had this blue. So I can create another, nope, wrong blue. But anyway, I can create another file called test3.txt. Which is in the same directory as the other ones as well. And this time, I'm not going to link it to the same file content and metadata on the disk. Instead, I'll link it to another entry. And that way, it'll be always visible that other than test.txt and test2.txt, which both look like perfectly normal files, they have their entry and they have their content. This one has its entry and it has its content. The only specialty is that this content is actually the same between the both of them. In this case, this file doesn't have its own content at all. It only has a name. And the only content it has is this reference to another file, which then gives us its content. So if you are a web developer, this is more like a redirect, that when we try to access test3.txt, it redirects us to test.txt, where finally then we can get some real file content. And the only difference in managing these is that we use an option for ln. And since we are talking about symbolic links, the option is named -s. And when we say, I'd like to sudo copy, because the order is the same as with the copy command, experiment to .txt into symlink.txt. Again, we get some output. I think that might be because I've also modified the ln command in my shell configuration to actually make some verbose output. Because that threw me for a little loop before, because I think the ln command normally doesn't make any output, and there might be a verbose option behind the scenes in action here. So if I do a cat symlink.txt, the effect is the same as with a hard link. I get the existing output of experiment.txt. However, if you take a look at the directory entries, there's a distinct difference, and that is, it's now perfectly obvious that symlink.txt is not its own file. It's only a pseudo file that points us to experiment.txt. And by the way, there's also another slight detail, and that's that normal files have a dash at the start of this entry here in this column, and symlinks have an L. That is the distinct difference between these. And there's another difference, and that's what happens when we remove the original file. With hard links, when we deleted test.txt, Linux only removed the directory entry, but didn't free up the actual file contents because they were referenced by another directory entry. That's not the case anymore with our symlink, because the symlink doesn't directly point towards the directory space. So in this case here, experiment.txt can be the only file connected to our file content. There's another hard link in the other directory that I've created earlier, but let's forget about that for a second. So if this was the only file entry referencing the text, this is experiment.txt, it would be freed up. So if I actually delete experiment.txt, Linux will for certain remove the directory entry, because that's what rm does. It might also free up the disk space occupied by the file. In our case, that's not going to happen because there is another hard link pointing to this, but that doesn't matter. If I do another listing, I have still symlink.txt pointing to experiment.txt. However, experiment.txt doesn't exist anymore. So if I try to cat symlink.txt, it tells me no such file or directory, even though symlink.txt does exist. But the file it's pointing to doesn't exist anymore. So while symlinks are more obvious connections between different files, they are also a little bit more fragile, because once you remove the original file that's pointed to, the symlink won't work anymore. So let me make a note for my future me. Visualize hard links and symbolic links in my slides. Okay. What is that? Anything else? let's take a look at the man page. So this is always helpful. Again, there is a backup option that if the target file already exists, makes a backup of that target file. The -d or -- directory option tries to hard link directories, which most often will not work because you can usually only hard link files which have their own content on disk, while directories do not have content in that sense. They only have a list of file entries in them. And so hard linking directories will most of the time not work. And even if it does work, it's only allowed to the super user, to the root user. So I think that's something you shouldn't even try. Symlinks, however, work perfectly well to create symbolic links from one name to a directory. Only hard link directories is something that you shouldn't attempt. There's again the interactive flag, and down there will be the -v, the verbose flag as well. And when I say flag, it's meant synonymous with option. Yeah, so there's not too much more that I'd like to cover here. There you have it. That's hard links and symlinks. By the way, let me open my speaker overview so I see what's coming up. And what is coming up is the df command, which is in general quite useful to see your free disk space. This one doesn't have too much magic like the ln command. df simply tells you your file systems and how much space you have. Since this is a huge list with all kinds of strange file systems, like here, for example, the /mnt/wsl file system that I discovered earlier today. No idea what that is and what its use is, and I'm not interested in that. So it's probably useful to give df an argument. For example, the current directory, because that will only give me the disk-free information for where I am in the moment. And that's my C drive here on my Windows machine. Another posture check. Thank you very much. I'm still wondering if I should get a new chair. If one of you has more experience in terms of ergonomics, I'm not sure. I'm reclined slightly here, so in order to look at my screen, my neck needs to be angled a little bit to compensate for this inclination of my back. And if I lean forward a bit to be perfectly perpendicular, of course my neck can angle back a little bit. And I imagine that might be more healthy. I don't have a headrest as well. I mean, a headrest would probably solve the issue, because even if my neck is straight and therefore angled back a little bit, it would rest on the headrest. So maybe that's another reason to get another chair. So even if the other chair is reclined the same way, say 2 or 5 degrees back, if it has a headrest, it would compensate for that. It would also make watching YouTube and Netflix here in the office a little bit more comfortable. Yeah, thanks for these posture checks. I should keep them at the iNode expense they're at in the moment, so I get more of them. Okay, so let's get back to df. I usually use df with the dot for my current directory because I'm interested in the space where I am and not in some esoteric file systems like they are listed here. Luxon28 says a good chair increases productivity times 100. Well, you're not wrong, actually. Especially if you take long-term productivity. I mean, I'm almost 52 now, and I intend to keep working for at least another 10 or 20 years. So, something like being actually able to sit at a computer is kind of important for me. Now, that's that. Now, this information is not too useful. I can see, okay, my disk on which I'm working is used to 64%, but I would have to read the absolute numbers to actually make sense of that, because I need to know how quickly I'm going to fill the remaining 36%. And so I still have, let's count, 260 megabytes available out of 456. No, we're talking gigabytes. Yeah, all these, of course, all these numbers here are in kilobytes. So we are talking about 260 gigabytes of 456 gigabytes are still available, so I don't need to worry. But as you can see, it's really hard to read that stuff. And that's why DF has a few useful options, mainly the -H option, which makes these numbers human readable. And that's much better now. And if you wonder why it's 249 gigs, but this here says 260 million, and it's also 436 gig, and it says 456 million, that's because we are talking not about 1,000, but 1,024 as the factor here. So these are actually gigabytes and not gigabytes, right? The funny sounding names are base 1024, and the normal kilo, as in kilogram or kilometer, are base 1000. So there's kilobytes with a small k. We are not seriously playing Christmas music, are we? No, we're not. No, it's that completely threw me off. Yeah, so the normal kilo that you're used to in kilograms and kilometers is base 1000. And so a kilobyte with a small k would mean 1,000 bytes. But since computers usually use powers of 2, we are talking normally we're talking about the factor 1024. And to differentiate the two units, we're not talking about kilobytes, but kibibytes, and not megabytes, which would mean a million, but mebibytes, and not gigabytes, which would mean a billion, but kibibytes. Which makes computers sound much more cute. Okay. Yeah, so I'm not going to dwell on df too much. df-h dot is what I'm using 99% of the time when I'm using df, because I want to see how much space do I have on the drive that I'm actually working on in the moment, and please display it in ways that I can actually read. Now, can I find out who's taking up 249 gigs on this disk? That's where another command comes in, called du. Excuse me. It doesn't show me how much disk space is free, but how much disk space is used. And while the free space on a disk is easily determined by taking a look at management data of a storage device, the disk usage needs to be calculated. Linux needs to go down a directory tree and look at the individual sizes of each file and add them up to create the result. And normally you can actually see that as well. So if I want to take a look at my different directories, let's go at least up one level. Yeah, that makes sense. We have 4 directories. So if I simply say du dot calculate the disk usage, as you can see, it goes down into each and every subdirectory and calculates the disk space taken up. This list can become quite long if you run it at a higher level up in the tree. So if I, for example, do a du, let's see, let's see how much my whole obsitive directory tree takes up. So we need to go up one level, which gets us to coarse, and then one level up gets us to obsitive. And as you can see, the list gets longer and longer, and if I go into documents, the list will scroll through. And oftentimes I'm not actually interested in getting all these details, and that's where the -s option comes in, which means give me only the sum of everything. And since that number might be a little bigger, I'll add the H for human readable as well. So now I get only the result that it's actually 428 kilobytes of text. Well, text doesn't take up much space, does it? And by doing a few du-sh strategically placed, you can then drill down and find out which of your subdirectories are the most egregious. All right. The upcoming command will take a little bit more time to explain, and it's almost 6 o'clock here, so it's going to be dinner time for me. So let's go and wrap things up.